what does Hive offer to you? Now, if you have a very large data set and you want to analyze the data, now the first thing what you would be doing, you will go here. Okay, you'll say, suppose this is a very large file. Okay, a large file called F1. Right now, your boss comes in and says, okay, find out um, all the people who have spent more than $5,000, okay, from this file. This is a data set. Now the first thing that will come to your mind, okay, MapReduce. But to work with MapReduce, you need to have some expertise in Java or any other API that supports MapReduce, correct? So you need to have some expertise, and MapReduce is not easy to program. It is a bit difficult, correct? So that is the first thing that you will do. Now, since it is a huge learning curve to learn MapReduce and then analyze the data, Hive comes to the rescue. So Hive has come to our rescue. Now, what is Hive? Hive is SQL for Hadoop. Okay, how Hive came into existence and stuff like that. Okay, now Hive was created at Facebook. On now, Facebook had a large pool of engineers who were well versed with SQL, and they wanted to use this SQL knowledge rather than, you know, make all the engineers learn MapReduce. So what they did is they built an engine. They said, okay, let's build an engine that will convert SQL queries into MapReduce code. So that's how Hive came into existence. So Hive, basically, you write an SQL like query which gets converted into MapReduce code. Okay, so that's what Hive is. Now, if anyone asks you for a definition of Hive, you can say Hive is a data warehouse infrastructure built on top of HDFS. Okay, so that is what Hive is in one line, right? Want to leverage Hadoop stack and technology to do warehouse and analytics. Okay, it's a Hadoop based system for querying and analyzing large amounts of structured data. It uses MapReduce for execution. Uh, it uses the underlying HDFS storage. Okay, now what's a typical use case? Typical use case, so we have a large amount of data, large data file, say 10 gig file, and we want to analyze this data. Now, as I said, MapReduce needs expertise, and in your place of work you have business analysts who do not know MapReduce. Business analysts, some of the business analysts may know SQL, and you have this large amount of unstructured data. What do the business analysts usually do? They run aggregation, summarization functions on tables, etc. Correct? Then they do data analysis, and then they analyze the data based on the above, and then they will have some pictorial representations like a bar chart like this or a pie chart like this and stuff like that. Okay, so they'll have this kind. Okay, so the typical use case is to place this large amount of unstructured data into some kind of a structure and allow the business analyst to run aggregation, summarization functions or queries and then analyze the data. So that's a typical use case. This is how you would use Hive. So large amount of structured data, we have to somehow give it some kind of a structure which will allow the business analyst to use these tools. Okay, so that's a typical use case. Now, when will you not use Hive? Okay, for that, let's say rather than just giving a statement, okay, don't use Hive in this case and don't use Hive in that case, we'll go back to the basics. Now, if you look at it, this is, say, let's say this is the HDFS system. Inside here, you have the name node, the data node, the job tracker, the task tracker. Okay, and they communicate this way. Okay, so this is HDFS system. Now, and you have a huge file here. Say this is file F1. Okay. Now, when you have this file F1 here and you write MapReduce code, MapReduce takes a very long time to run. So, the latency is an issue. So, you wouldn't use MapReduce when you have online transactional processing. Say you are on a website and if you want some data out of that system very quickly, you wouldn't be running MapReduce on this large amount of data and expect the user to still be there till the result comes back. So latency is an issue, and MapReduce you can't use it on OLTP, online transactional processing. So based on this, because Hive converts everything to MapReduce, it automatically means that Hive is not suited for online transactional processing. Correct? So that is point number one. Hive, where latency is very important, you cannot use Hive. Second, now I said Hive is SQL for Hadoop. When I said SQL for Hadoop, it means it has got tables, it has got views, etc. So does it mean that it will allow you some kind of crude kind of an application? No. So even a crude application is not possible, because by the very nature of HDFS, what is the nature of HDFS? It is write once and read many a times. If I write this file once, I have to read this many a times for analysis. Correct? I can't be using this for finding a particular piece of data in there. Say a small chunk of data. Say find this. Even to write some find, I'll have to write a MapReduce code, which will take a very long time to run because it involves creating mapper task, reducer task, etc., and firing up the JVMs and things like that. So crude kind of application, you should not use Hive because it's impossible. Okay. Also, when you have a very small data set, you'll be better off by writing MapReduce at that time, because the amount of infrastructure involved in creating in setting up Hive, having an RDBMS to store meta information and things like that, so all of that wouldn't justify. So you rather do MapReduce, and even MapReduce is not the right thing to do. You might use some other tools for extraction data, because by the very nature again, HDFS is for large files. Default block sizes in HDFS are 64 MB. Now if you have very small files, the name node will be storing a lot of meta information and this will get heated up. So again, for small data set or for small files, this is not very useful. Okay, so by the very nature of HDFS, all of these things cannot be done in Hive.